Well, why don't I take a moment and welcome everybody to our session here. I think this is our either fifth or sixth. Quinn, you're right in the middle of our sessions here. We saved the best for the middle. So
Good.
appreciate you jumping on. We've, these sessions have been a way for both our existing students and some prospective ones to learn a little bit about the research that's going on at NYU CCS with faculty members like yourself. So we spend about a half hour doing that. But what I want to start with, I know we've had a lot of people asking about our Cyber Fellows program. I want to mention it now real quickly, because if you're interested, if you're listening and you want to learn more about it, just drop us a note here in the chat. Just drop a private note and we'll get some information to you. But basically what it is it's a master's degree, taught by this community, where you get scholarships up to about 75%. I think you can potentially get a master's degree for about $16,000. That's unheard of from a school of NYU's caliber. So it's a wonderful opportunity for some of you who've been wondering, hey, is it possible to do this? I know tuitions are rough. I'm an NYU dad. I've put 3 kids through the school. My family is, we were committed to the school. And tuitions are tough. So this is a wonderful scholarship program. So if you have some interest, it's a 3-year program. It's online and you can do it while you're working. There's a lot of industry partners. I've been involved in these types of things for 30 something years. I think, so if you're listening and have some interest, drop a note. I see there's a couple people pointing out that they're in the program now, really like it. So let us know. We're happy to get you some information. So first off, Quanyan, thanks for making some time. And again, that's of all the backdrops we've had yet, that's probably the coolest one. You look like the commander today.
Well, you are the commander-in-chief now.
Yeah, if only. I wish I could do it. But listen, our favorite thing to do to start is, because there's so many students thinking about careers in this area. Tell us a little bit about your journey. You've been affiliated with some really great schools through your education and your postdoc and now as a professor. How'd you get interested in all this? I'm assuming you were good at math when you were a kid or something. And
Well,
what was your story?
well, I'm happy to share these stories and so that we can make it a little bit informal here. So I remember when I was a undergrad, I was, I always, when I was taking an exam, I was writing my name, Quanyan. It actually happens to be a quantum mechanics exam.
Yeah.
I realized my name, first 4 letters of my name is actually quantum. So, and then I started to say, okay, maybe I'm meant to do quantum mechanics, in my life. And then I started a website called mrquantum.com. That's the time when I was an undergrad. And then I realized, and at that time I was so excited about physics and I wanted to study more about nano technology. And, but then I realized one thing, when it comes to nano, you really need a lot of good equipment, because you cannot really do things by yourself. I mean, intellectually, you have to use, have to be a big team, and a lot of people have to work together and get something done. And then I remember at that time, I think, well, is there something that I can just do and and by myself, because I'm tired of just being asked by the PhD student at that time, asked me to do some data analytics, because they just see undergraduate students totally safe when they're touching the equipment. Then I said, okay, maybe that's, if I really want to become a person in nanotechnology, I have to wait to become 10 years to get there. Maybe I really want to do some, I just want to get into research quickly. So then I chose control systems, because at that time, that's the only discipline that I have never taken a course with. So I said, okay. And it happens at that time, there is a professor teaching a game theory course as a part of the control curriculum. And I was very excited about it because
this was at the University of Illinois, correct?
That was at McGill when it was.
At McGill, that's right. Undergrad at McGill.
Undergrad. And I was always wanted to take a course in economics and game theory, because I was fascinated by the movie A Beautiful Mind. And I said, okay, I was just curious, what is the theory is about, and how this theory led to a Nobel Prize and such a legendary story about John Nash. And then I was really just curious, and it just happens that they offer this course in your department. I said to myself, why not just take this course and figure out what it is, right? And then I realized I realized that if you're taking too many courses in your final year on a certain topic, and you plan to do a PhD or a graduate program, that means that becomes your area. So accidentally, I just became, I said, okay, we actually apply for graduate school. Okay. And everybody look at what you have taken in the final year. And I've taken a lot of courses on control and game theory. So it sounds like a reasonable graduate school program is a combination of all of them. So that's how I went to this area. I would say accidentally, but then I realized that, what is the exciting thing about this area, control and games, and in general, and mathematical aspects of electrical and computer engineering, is that it really shapes you, not just because of the mathematics, it shapes you to become a thinker. And you can understand things more fundamentally than just looking at, okay, let's just do experiments to figure out what it is. And you actually can go deeper into the problem and looking at asking yourself, what fundamentally this problem is really, really about? I mean, one good example is communications. And I think a lot of people think about communications is just some a wave propagation from A to B. But what exciting thing from electrical engineering and Shannon's viewpoint is that actually there is entire theory, information theory, that is associated with wireless communications. So I think this is fascinating. So people think at a different level, and that gets me thinking, wow, this is a really academic, and this is really exciting. People, we can look at the same thing, but for some people looking at the same thing, you look at it and you see, oh, it's just a smile. And what I see is something more than just a smile. And this is what I told my student. What is the great thing about doing research and being a graduate student is that you are able to see beauty in unlikely places. So even though we see the same picture, see the same Mona Lisa, but you see a beauty that I didn't see. And this is why it is so exciting to do research. And this is why it brings us to the graduate studies program. And that brings us to a PhD program that give us not just knowledge, but also a perspective, a perception, a totally new angle looking at this world. And I think this is so important. And I think this is what makes us winning and give us advantage. And I always say, this is probably the factors that makes our program so unique.
You think that in a sense that ability to see beauty in mathematics or in something conceptual, physical, is that kind of the calling that brings you to the PhD program? We both know you don't do it to make more money at work or something. That's dumb. Right. Is that really like, if there's people listening and think, gosh, I wonder if I should do a PhD. Do you think that's something that's a pretty good hint that you might enjoy research?
Well, I think the thing that gets me to research, I think it's really about being curious. I'm just, I remember I was written a paper. That was like when I was in a master's study. I was just curious about, is there any trade-offs between efficiency and fairness? At that time, and I don't think, that was probably 10 or 15 years ago, I was thinking about this question. I was written a 2-page paper, and it's totally hobby research because my master's thesis is not on this. And I was thinking, wow, that's interesting. I was asking myself, well, it's great to think about it. Is it true that, it can be fair, but compromise with efficiency? But if you're efficient, then you're not going to be fair. So is there any contention between these two concepts? Well, I think it's just fun to think about them. And who knows? 15 years later, people will talk about fairness in machine learning. People are talking about so many issues. I think I take great delight in the idea that thinking makes a good human being. I think the one thing I always tell my students is that I I think we are here, and we're not here trying to train students to become laborers. I'm talking about PhD program, especially for PhD students, because 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 it's so easy right now to learn something online because all the courses are online. If you just want to learn something, it's available online. So Wikipedia, you can, if you do not know what is advanced persistent threat is, okay, go online. Go online is, I think it's a better source in terms of knowing what it is than me telling you in person, right? Because there's so many details, so many examples. And, but I think, we're living in a world where information is so much available online. The question is, what makes our education valuable? Well, the thing that makes our education valuable is not because we're teaching students what advanced persistent threat is. We teach people to think in a different perspective, how to think, how to fuse information, which information to look at, how to pick information, and how to actually form an opinion towards something. I think these things are more valuable than just knowing something.
That's such a nice thought. That's really well put. Now,
And,
tell us a little bit about your work in game theory. You and I spent some time a couple of weeks ago connecting it to weird things like insurance and so on. You've got a lot of creative ideas. Tell us about your work in game theory and what you and some of your students are doing.
Right. So I think first I'm so fascinated about game theory because in my first class, I usually show a slide. I tell people game theory has been used in many disciplines, including biology, business, and management, and communications, civil engineering, and security, so many areas. So I told the students, if you do not know what to do in your life at this moment, start with game theory. Because why? Because eventually you learn the tool, eventually become useful somewhere, right? Because it has application everywhere.
Yeah.
Or if you know what you want to do in your life, also learn something about game theory because it will help you to do this thing better. So I think this is what makes, it's such an exciting topic. And from my side, I focus more on its applications and theory in cybersecurity because I think it's a natural application in a way. You can think about a lot of security problems if you want to think about the fundamental properties. It's really about a interaction between a defender and attacker. Defender is going to design something, an attacker is trying to either to break it, compromise it, or find ways to do it. And then defender is going to fix it. And then attacker is going to break it again and fix it and break it again. So I think these type of interactions could be a short-term interaction, just happening like 10 seconds. Or these interactions could be even a long-term interaction in the sense that, well, it could be the evolution of the software, evolution of hardware over time. And I think it's important to help us to understand how you actually understand these interactions, not just by fixing the problem when the problem occurs, but actually ask yourself, what is the long run perspective towards security? I mean, if we keep on doing the way that we are fixing the problem, or attacker is keep on doing the same thing that he is doing, are we able to win this game? Are we able to win in the end? Or eventually we are just doing every time, and when there's a problem occurs, we just fix it, and then eventually we are just we're never able to solve the problem.
In terms of applying game theory to cybersecurity, is it this idea that in any given situation, if I had all the right factors, there's this determinism and there's always the right move, like in chess? Or is it just way so complicated that really just a matter of using the game theory to drive me toward maybe better strategies or optimizing the likelihood that if I'm a defender? How does that work? Is there determinism or is it too complicated for that?
Well, I think it depends on what the level that you're looking at. For example, we can talk about insurance, cyber insurance, and then that's probably a higher level of looking at it in the sense that we are probably just look at economic perspective or a risk perspective. So we want to develop certain sort of risk mitigation schemes or transfer schemes so that transfer risk from A to B so that we can able to reduce the risk risks that we actually have in your system. So this is something high level. Or we can zoom down onto a specific system level. Like, say, let's talk about network security. Think about APT. Attacker is going through several stages of a privilege of escalation, ladder movement, eventually try to capture the physical system, like say a control system in particular. Like say you can try to compromise a sensor or try to compromise an actuator in a network control system, for example. So in these type of problems, you can also try to understand these interactions between attacker and a system is actually multiple stages. So it's like playing chess in a way. Mm-hmm. So or playing Super Mario, like round one is try to get a password. Let's play the game, but try to get a password. Round two, let's find where the right asset is. It's lateral movement, for example. Round three is try to really launch an attack so that you have the sensor, where is the right sensor is. Try to search for the right one. So you can think about it's a multi-stage game. And let's say conceptually speaking, now the question is how you actually, which aspects you're going to look at, what's the type of strategy that you look at, depends on what are the actions or what are the designs that you have in your system. For example, I can design honeypots. Maybe this is a way that I can capture or at least detect the attacker and to see where he is, as in when he triggers the honeypot, for example. Or I can change my passwords, or I can randomize the address, or I can put some honey sensors sitting somewhere. So there are many things, redundancies or deception per se, that can be done in your system. And these could be your strategies. Or the strategies could be like, let's just do the patching. So how frequently you're going to do the patching? How frequently you're going to do changing your password? How frequently you're going to design your honeypots? And these are all big factors that come into your defense, right? Thinking about that. Just like what I said to the students, when it comes to Angry Birds, I'm really bored of playing Angry Birds because it's always the same game, right? What if, the designer can actually change the scenarios, even though the same game, but they can change the scenario a little bit and make it more, it has more surprises, it probably make the game more fun. I think the same thing, right? So when it comes to security games. So if the attacker knows, okay, this is a setup of this Angry Bird setup. So maybe he tried by trial and error, he figured, okay, this is the way I'm going to win this game. But instead, you can actually have some surprise factor sitting somewhere and always changing the game a little bit. And so that either to bring surprises to the attacker, so they never able to win, or reduces his probability of winning, or at the same time, making sure that you will be able to defend yourself from these type of attacks. So I think there is a lot of analogies that you can make between a game that we play and a security game that we see in cybersecurity context.
Now, how did you connect this up to the cyber insurance equation, like for determining insurability and stuff like that? You were sharing with me some of the work you did.
Yes.
Worked on a very interesting paper recently. Tell us about that work.
Right. So the thing that motivates us to work on this is, we ask ourselves the following question, right? So how does cyber insurance is going to be different from the insurance that we have seen, life insurance or your house insurance? So what are the fundamental differences? And then we realize one of the interesting differences is that there is an attacker in this game. Right. So thinking about life insurance, you're insured against nature. Well, nature is not an attacker.
Unless God is the attacker.
Right. So these are, it's easy to quantify, right? So how what is the likelihood you're going to get sick, and what's the likelihood, something is going to be broken down. I think it's because if the nature is the adversary, let's say, then it's easy to quantify.
That's right.
But when it comes to an adversary, well, it's really hard because it's not nature, right? Then you actually have to, but you still want to really categorize in the same way, like say in the same fashion as how we capture nature. then we really have to establish a model to describe what attacker's incentive is. Nature may not have incentives, but attacker has incentives. Attacker has objectives. Attacker has its own, what are the actions he can take, and as well as what type of attackers, right? So, and also unknowns. So, there may be a lot of things that we know, we assume, but it may not be correct. So there's unknowns sitting somewhere. So now the question is, if we want to use this similar, but not exactly the same, insurance framework, then instead of just quantifying the risk in nature, we have to quantify through a game between a defender and attacker. So in other words, using games is actually a way to help us to quantify the risk, just like we use statistical tools to quantify what's the likelihood that we're able to get sick, for example. So obviously, there are limitations here, or let's say, instead of calling limitations, let's call it challenges, right? I think one of the important challenges is how can we get these attack models correct, right? And how wide assumptions of attackers' best behavior, why attacker is acting rationally. And these are all important challenges for us to work with. But I think nowadays, with a lot of tools like machine learning, and with a lot of data scientific tools, actually putting them together, I think actually would help us to understand attacker models and through the data. I think just like the way we quantify risk of getting sick by using a lot of the data, a lot of the cases that we've seen in the past. So I think we can leverage a similar type of fashion to quantify that. Yeah. So I think this is there's a lot of exciting research to be done. I still see it as a emerging area, and I guess Ed, you can comment on it.
No, I love it. I think it's great. There's some questions here from.
Oh, really?
Okay. One is that this is from Nalan asking, how do you formally get started in a research area, but kind of pointing to game theory and cybersecurity? When you find yourself interested in an area, how do you get started with something like this? Do you read papers? Do you go to talks? What's the first steps that someone takes? And I would say, by the way, take a look at our program. Like if you're interested in this, we'll get you involved in some courses in a group. But generally speaking, how does one go about, once you have an interest, how do you spark that interest with some work?
Very, very simple. 2 words. I told the students too. You start with your common sense. Don't read. That's true. Don't read papers, because I told my students, why we should not read papers, because if we start with reading papers, you start to become, to frame yourself in a box. We ask ourselves to think outside the box. So how to think outside the box? 2 words. Use your common sense, because a lot of times common sense is so valuable. And I would say start with the thinking by yourself. What do you think is a logical way of looking at this problem? Maybe great minds think alike. And then after you thought about it for a while, maybe there's something that you do, some hard questions you don't know how to answer, that's fine. Then you go to literature and to see whether people have addressed that or they have not. Then you can form an opinion. If you just blindly go into literature without your common sense, you very easily to frame yourself in a box. And then after that, it's hard for you to go outside of that box.
Yeah. My experience, I know I've heard Richard Feynman say this, and I remember the great mathematician George Polya said this as well. And it was, all good things start with guesses. Where, right? Where you have some common sense, that's the best way. It sounds so non-scientific, but it is pure science. And everything starts with you or me or anyone saying, you know what? I'm guessing. I think this to be true.
That's right.
And then everything you do is around either building evidence that you're right or doing experiments. And science really does, I think, frankly, most computer science education, and definitely math education, does a bad job of showing how you do math. It shows you the math done, and it shows you programs that are written and designed, but we don't, I think as a community, we could do a better job of showing people how to
That's
do
true.
the math instead of
That's
see
right.
it done, right?
That's right. So I usually don't encourage students to go directly to the math. I think the first is about common sense,
Yeah.
and have a conjecture, common sense, have your opinion, and first your opinion could be wrong, but it doesn't matter. Then you go literature to ask yourself, are you correct or wrong? Right? If you're wrong, you learn something. If you're correct, you're happy because the great mind think alike, isn't it? So, and either way, I think it's great, and I think that's how you get things started. And I think also another thing I think is important is ask yourself good questions, and that means ask the question that not normally people ask. I think this is also very important when it comes to thinking and when it comes to research. And I usually tell the student, this is not just about research, but it also happens in the business world too. If you want to be a leader in your business world, you should think. You should not just do what other people do. You should ask yourself using your common sense, what would be the best product there should be, right? Not just say, oh, because people do this, that's why I do this. That's not the right attitude.
No, that's good advice.
I think that I think the second thing is that I think this is what I told the students maybe it's also good for our encourage everybody to go into our PhD program, is that I think this is the way we train our PhD students to become thinkers. We now try to making them laborers, right? So I mean, thinking is more important, more valuable today than just knowing, oh, I know how to do deep learning by using this software. Well, what happens 5 years later? Who knows what's new things come up.
You have to be able to think. Yeah,
that's right.
Got another question here from Lindsay.
Okay,
she's asking about the attacker payoff, and I'm going to embellish a little bit and add maybe the game theoretic piece to that. Is there an opportunity maybe to use some of the work that you've done to figure out whether the payoff, because that's an important part of any game theoretic exercise, what do I get out of it? You think there's some opportunity to sort of guesstimate what attackers might try to do using game theory?
Right. So absolutely. I think in a classical setting, it's always assumed that, okay, attacker has presumably have this, attention, or intention to do something. But nowadays, there is so much data available, just like we are using, like say, deep learning, try to figure out a pattern. You can use the same thing, same way, try to figure out what attacker is trying to do. But obviously, this is a game theory plus something. Here, this is game theory plus learning, right? So, and also game theory maybe also can be connected with psychology as well, because maybe the attacker is a human being. So you also want to understand its cognitive limitations and what his perception is. The way you think, it may not be the way he thinks. So I think there is a lot of game theory plus. In other words, game theory plus something actually will help you to solve these new challenges.
That's excellent. That's excellent. We're getting to the top here, and I want to ask you something that we've asked everyone.
Okay.
And that's that we have so many people on the call here who may not be New Yorkers, might not know much about Brooklyn, might live in a place about as far from Brooklyn as you can get on the earth. And I'm curious, what's been your experience living and working? You've been in a bunch of different places. You've been in Illinois and in Canada, and I know you spent some time at Princeton. What's been your personal experience living and working and studying and researching in New York City?
Well, let me say, I mean, my impression of being in New York or NYU in particular, I think New York is a place with people who like to take risks. So if you are a person willing to take on new challenges, if you're a person willing to take risks and have high reward, come to New York, come to NYU, right? Because this is the culture, and this is something that is exciting about being New York. I think living in New York is, first of all, one thing that had come to me is that there are so many smart people here, and they can happen. I mean, it can happen that the person you talk to on the street, it can be somebody so famous you just don't know. Right? I remember I was talking to somebody in a conference that, I used to be in another building, and I was so surprised that, there was a professor sitting on the higher floors, and he is one of the New York Times bestseller author. I was, wow, this is, and that person is just next door. I used to read his book, right? And not like in New York, but when it was like in far away places, and now he's just upstairs. I think this is remarkable. I think there's a lot of smart people in New York, and it's very easy to find these smart people. And the second is a place where allows you to take risks, and because people have that mentality. And I think taking risks is very important. You
mean intellectual and research risks.
Right.
Yeah.
Exactly.
Right.
So because you have to think differently, right? You cannot just, let's do this. Let's just add epsilon extension to it. Well, that's not good enough for us, right? We want to take bigger problems. We want to look at it, explore bigger risks. We want to understand the bigger problems. And you have to be more capable than just writing a paper. You have to become a thinker.
Yeah, I would totally agree, and I think you mix that up with the wonderful diversity that we have in our city, and it's just it's a nice experience. I hope for some people who are maybe pondering, perhaps coming to New York, I hope they'll come and visit. It's 100% safe. It's one of the safest places in the world nowadays, and
I think so.
And I think we've managed this COVID reasonably well. Seems like
we're seeing the numbers are dramatically down compared to other places.
Yeah, we've done well. Well, Quanyan, I want to thank you so much for just wonderful ideas on learning and thinking. I think your students are very lucky to have you. And again, for anybody who has some interest in becoming part of our community, just drop us a line. You can do it in the chat, or you can send us a note afterwards. And hopefully we will see you all again next week. We'll have another one of these sessions. And on behalf of the whole group here, I want to thank you for being such an interesting, I knew you would be.
Yeah,
thanks for sharing. We had a lot of fun. Thanks, everybody. We'll see you all again next week. Take care.
Bye. Take care.